Yeah, welcome back. In the last video we have seen how the dry cell is working, right? What is cell, what is internal resistance, what is EMF, and all we have seen the last video, right? And now what you are going to see now, if the cells are connected in series and parallel, what will happen? And in this video we are going to deal with the cells are connected in series. Okay, assume that here I have one dry cell which is AAA battery. Okay, the AAA battery having 1.5 volt, and similarly here I have one more 2-second dry cell, okay, which is also AAA battery 1.5 volt. Now what you are going to do in the sense, these two cells are connected in series. So as we know that this one is a positive terminal and this one is negative terminal. How we are going to connect in the sense, the first dry cell of the negative terminal is going to connected with the second cell of the positive terminal. In this way we are going to connect it. This is called series connection, right? And if you are doing like that, or if you are connecting in series as like that, the negative terminal of the first battery is connected with the positive terminal of the second battery, and this the total voltage becomes add up, that is 1.5 plus 1.5, that will give 3 volt, right? And the EMF also is going to be increases, E1 plus E2, total EMF is equal to E1 plus E2. Suppose we can also connect as like that, negative and negative, this will gives minus 1.5 minus 1.5, that will give us nullify 0, it will gives. Similarly, if you have the third one, if you are connecting with here this is positive terminal, right? Third one, if you are connecting a negative terminal of the third cell is connecting with the positive terminal, then it will be added. So similarly we can do for number of cells, n number of cells we can able to connect in series, right? Now we move on to this topic, the combination of cells in series. So here I have first cell, here I have second cell. The first cell having the internal resistance R1, the second cell having the internal resistance R2, and the first cell having the electromotive force E1, and second cell have the has the electromotive force is E2. Now the current will flow from positive terminal, right? So its current outward in direction, right? And similarly this is negative, right? So current will inwards towards the negative terminal, and similarly here also from the positive terminal is coming outward direction, and here it is inward direction, towards it's coming towards negative terminal, right? So understand the current flow in that diagram. So here we have used two different cells, which is here I draw the equivalent diagram of this diagram. So here I have the equivalent electromagnetic force, and the current will flow from the positive terminal, and here the current will inward direction towards the negative terminal, right? And the total internal resistance, that will gives R suffix EQ. Here the electromagnetic force is given as E suffix EQ. EQ stands for equivalent, right? Now here I note down point A, point B, point C. Point A in the left side of this battery, and point B is right side of this battery, and similarly for this battery B is left side and C is right side. Okay. Now what you are going to find out, the potential difference between A and B, and the potential difference between B and C. At last we are going to find out the potential difference between A and C. Okay. Now the potential across V suffix AB. V suffix AB means the point A and B, between the point A and B we are going to calculate the potential difference. So V suffix AB is equal to VA minus VB, right? VA minus VB. VA is higher potential. Remember that positive terminal have higher potential and negative terminal has lower potential. So higher potential minus lower potential, that will gives. In the previous video we have seen that VA minus VB, right? What is VA? Is from the positive terminal, right? So that will gives the electromagnetic force E1 minus what is IR1? Yes, that is the current passed through this cell, right? So I into R1. R1 is the internal resistance of this cell. and similarly the potential difference, PD stands for potential difference across BC. So, across BC we are going to find out. So, here the positive terminal. So, V suffix BC is equal to VB minus VC. VB is higher potential, VC is lower potential. And here also, what is the second battery electromotive force? E2 minus, what is the internal resistance of the second battery? R2. So, E2 minus IR2, right. Now, what you are going to find out? The potential difference across A and C. So, the potential difference across V suffix AC is equal to VA minus VC, because this one is positive terminal and this one is negative terminal. So, higher potential minus lower potential, right. And very careful that here I wrote VA minus VC, right. So, how I am going to derive this equation is equal to VA minus VC, here we have, right. Yes, okay. Here what I am going to do, I am adding 1 VB and subtracting 1 VB, right. So, VA minus VB plus VB. So, this term will be cancelled as per mathematical rule, right. So, what is VA minus VB? Here we have wrote E1 minus IR1. So, what is VB minus VC? That we have wrote E2 minus IR2. So, VA minus VB I wrote as E1 minus IR1, and this symbol is plus, adding. If you are connecting, by the way, the negative terminal is connected with the positive terminal of the second cell, that time it will be add up, right, because this term becomes plus, and E1 minus IR1 plus E2 minus IR2, because this value becomes E2 minus IR2. So, here we have E1, here we have E2, take it as E1 plus E2 minus, here we have minus I, here we have minus I. So, take it as common, minus I into R1 plus R2, close the bracket. So, what is this E1 plus E2? That is called equivalent electromotive force. This equivalent electromotive force is E1 plus E2. What is this R1 plus R2? That is called equivalent resistance when connecting in series. So, R1 plus R2 is equal to R suffix EQ. So, this is equivalent electromotive force, this is equivalent resistance, and here we have, instead of this term we can write E suffix EQ minus I into R suffix EQ. From that equation we can write EQ is equal to E1 plus E2 and R suffix Q is equal to R1 plus R2. And what we are going to know about this concept here, kindly note down here the equivalent EMF of n cells. Here we are discussed with only 2 cells. So, the equivalent of n cells, if you are connecting with n cells like the way, so is equal to the sum of their individual EMF. So, we can add each and every cells as summing up, that will give equivalent EMF of that system, series systems, and this factor. So, E1 plus E2 plus E3 plus E4 plus E4 up to E suffix n, that will give equivalent electromotive force. Then the second point, the equivalent internal resistance. The equivalent internal resistance R suffix EQ is equal to of n cells is equal to sum of their individual internal resistance. So, R suffix EQ is equivalent internal resistance, that is equal to R1 plus R2 plus R3 plus R4 plus R5 and goes on up to R plus n for n cells. So, here I wrote R suffix EQ is equal to R1 plus R2 plus up to R plus n. This is a concept we are going to understanding here. So, the total the equivalent EMF is equal to sum of the individual cells and sum of individual EMF, and equivalent internal resistance equal to sum of individual internal resistance. So, these 2 points are the concepts in this. Okay. Suppose if I change this polarity, so here we have plus, here we have minus. Suppose if I change, this one is minus and this will becomes plus. So, what will happen? So, this factor becomes E1 minus E2, the equivalent resistance becomes E1 minus E2. Let us see once again. Suppose I changed here, okay. The first battery negative, the second battery negative is connected. In this way, the current will go outward direction from the positive terminal. Now, down here the current will towards the negative terminal in both the case. So, that time it will give negative difference value between the equivalent EMF. So, and here the second battery we have the positive terminal, the current will outward in direction towards C, point C. right? Okay. Now, the equivalent electromotive force is equal to E1 minus E2. Why? In the sense, we have the point B, C, right? The potential difference across the point B and C, that will use minus E2 minus IR2. Why we are given as minus here? Because which is in the opposite direction, right? So, this is in opposite direction. So, that minus E2 minus I into R2, because current I flow through this second battery and which has the internal resistance as R2. Therefore, for this setup, the equivalent resistance is equal to E1 minus E2. And similarly, if you are connecting the third resistance as properly, minus and plus, that time E1 minus E2 plus E3 we can write similarly. Yes, I hope you understand well. Thank you.